The next example that I want to talk about is a four-function calculator that can handle slightly complicated arithmetic expressions and figuring out what they evaluate to. Now this is useful for homework 5, that's what we're building towards, where we're going to start working on building a command shell. But for now we don't have to worry about homework 5, we can just look at the slightly simpler example that we're going to be dealing with right now. So the idea is that we want to be able to take arithmetic expressions like 1 plus 3 and then evaluate them. In this case, that's going to evaluate to 4. Now that's pretty simple. We did that in homework 2, I think, but we can make it a little bit more complicated. We can say what is 1 plus 3 plus 2. So that's going to evaluate to 4 plus 2 is 6. There's 4 functions, so we can get into what is 1 plus 7 minus 4. So 1 plus 7 is 8, minus 4 is 4. We can get a little bit more complicated and ask what is 2, well, it's going to be a star, so 2 times 2 plus 3 times 4. And now this is where this gets tricky, because if you remember, I don't know, middle school or whenever you had to start dealing with this stuff, we have order of operations. So we're supposed to evaluate the multiplications first, so 2 times 2 is 4. 3 times 4 is 12. And then 4 plus 12 is 16. And that's the result that we want to get. We can get even more complicated if we start adding longer expressions. And conceptually, there's not even a limit to how long the expressions can go. But I don't know if that's the problem that we want to solve right now. The problem that I want to think about right now is how can we evaluate expressions like this one in general relatively efficiently. And the approach that we commonly, or the approach that I want to talk about to this, is effectively building an interpreter for a programming language. This is a programming language with very simple expressions. The expressions are just arithmetic expressions. But to build an interpreter for a programming language, we go through a couple of steps. So we're going to read a line of text. Then we're going to tokenize that line of text. So this is going to get us a string. This is going to take our string to a list of string. Then we are going to build a abstract syntax tree. This is the parsing step. I guess we can write parse here. This is going to take our list to our tree structure. And then finally we have an eval step where we're going to take AST and evaluate it to a single value, which in this case is going to be the number that this evaluates to. Now, if you had Fundies 1 with Olin Shivers, or someone who likes to use the sort of metacircular evaluator or build your own interpreter material that Olin Shivers likes, then you've done a lot of this in intermediate student language. But doing it in C is still a useful exercise. For those people who didn't have Fundies 1 in the Olin Shivers style, doing it in C is good to do for the first time, and it's going to end up being useful for this upcoming homework. So we're going to go ahead and walk through that in the code example in a little while. But let me draw out the steps first. So we have something like the string 2 times 2 plus 3 times 4. And it's not entirely clear looking at the string whether there's spaces or not. Let's say some of these things are spaces and some of them aren't. Let's say there are not spaces around the stars, but there are spaces around the plus, just arbitrarily. Next step is we want to tokenize it. And in this particular case, that's going to give us a list of strings that are all of length 1, although if we had bigger numbers here, we could have the numbers be strings that are longer than length 1. So that's going to give us the list of 2 star 2 plus 3 star 4. So there's our tokenized input. Then our tokenized input is going to get parsed, and that's going to generate an abstract syntax tree. And the tree that we're going to get has a root of plus, and then it has 2 children. We're going to end up with 2, 2, 3, and 4. So we need to build this tree, which we need to represent as a data structure in our C program. And then this thing is going to get evaluated, and we're going to do a recursive evaluation function. So we know that 2 times 2 evaluates to 4. We know that 3 times 4 evaluates to 12. And we know that 4 plus 12 evaluates to 16. And that's going to end up being the result of our evaluation. So that's the plan. Now let's go ahead and try to write the code.